Welcome, everyone. My name is Noeli, a ScyllaDB technical engineer, and I will be your host for today's webinar, Overcoming MIDI Streaming Challenges with NoSQL. MIDI streaming is part of our daily lives nowadays. The number of key players within the streaming industry has been growing at a very fast pace. With so many options, it is no surprise that one of the business challenges of MIDI streaming is how to attract more consumers to an engaged experience. Therefore, let me pose a question. What are going to be some of the aspects that will differentiate one platform from another, and how can we help? For those of you who are not familiar with ScyllaDB yet, it is the database behind game changers, organizations whose success depends upon delivering engaging experience with impressive speed. ScyllaDB was built with a close-to-the-metal design that squeezed every possible ounce of performance out of modern infrastructure. This translates to predictable low latency even at high throughputs. With such consistent innovation, the adoption of our database technology has grown to over 400 key players worldwide. Many of you will recognize some of the companies among the selection picture here, such as Starbucks, who leverage ScyllaDB for inventory management, Zillow for real-time property listing and updates, and Comcast Xfinity, who power all DVR scheduling with ScyllaDB. As it can be seen, ScyllaDB is used across many different industries and for entirely different types of use case. More than often, your company probably has a use case that is a perfect fit for ScyllaDB, and it may be that you don't know it yet. So, I am Noeli Medina, and as a technical support team leader at ScyllaDB, my ultimate goal is to ensure customer satisfaction by providing exceptional service. I am a firm believer in taking on new challenges and learning new things, which has helped me grow both professionally and personally. With me today, I have Felipe, who's going to give us an amazing talk around MIDI streaming. Hi, Fe. Would you please introduce yourself?
Thanks, Noelle, and hi, everybody. Thanks for your attendance today. And well, what can I say? May the 4th to be with you. We are doing a MIDI streaming webinar today in May the 4th. So very interesting, right? And no, this wasn't combined in case you are wondering. So I am Felipe Mendes, and I work as a solution architect at ScyllaDB. And my main role here is to help ScyllaDB users along their journey to ensure that they succeed in part of becoming part of our selected list of game changers, as Noeli just described. As for me, well, I am a published book author with years of experience with Linux and other distributed systems. And of course, just like most of you here are, I am yet another open source enthusiast. Okay, so enough talking about me. Let's begin. So let's quickly start with our agenda for today. First, let's do a quick refresh on what we understand by streaming. Then let's do a deep dive into some MIDI streaming use cases, cover some of the inherent challenges of those workloads with respect to latencies, throughput, geo-replication, and how NoSQL databases such as ScyllaDB can help. We will then discuss some use cases that are a natural good fit for NoSQL as it relates to MIDI streaming. Here specifically, we will discuss known use cases that run on top of ScyllaDB in production today, and also describe their primary characteristics. And finally, we will conclude talking about the future of streaming media and how it relates to NoSQL databases. Okay, so let's start with a very simple question for us to reflect upon. And for that, I'd like to bring Noeli back. Noeli, what is streaming for you?
Spotify and Netflix.
That's a great answer. So yes, you are not incorrect, but also you are not entirely correct. So, when I was invited for this webinar, I really got into thinking on how we would be talking about media streaming without first going through all the fundamentals of the streaming world beforehand. So I started doing some quick, and by quick, I mean, I went to Google. So I went to do just quick research over what the meaning of the streaming word currently is if I were a regular user. And just the results that you are seeing in your screen are essentially the results I've got from Cambridge and Oxford. The definitions I've got from Cambridge and Oxford. So let's take a look at some of these. First definition, the activity of listening to or watching sound or video directly from the internet. So from my perspective, this is basically enjoying life. This has nothing to do with streaming. Second definition, playing continuously as sound or moving images are sent in a flow directly from the internet to a computer. So from that perspective, from that definition, an animated GIF in a loop can be described as streaming, right? Third definition, the act of sending sound or video to a computer, mobile phone, etc., directly from the internet so that it doesn't need to be downloaded and saved first. Okay, so at this point, it's very clear that our definitions of streaming have something to do with audio and video and the internet. But is that all that there is to know about that streaming word kind of thing? Let's take a look at the fourth and last definition that I brought. A method of transmitting or receiving data, especially video and audio material, over a computer network as a steady, continuous flow, allowing playback to start while the rest of the data is still being received. And I must admit that I almost fell into the trap of this definition. I read it and placed some thought on it for some very good minutes. And then I decided to drop it, only do it to the playback word. If it had ended within the continuous flow part, I would probably be happy with the definition, okay? So as a result, I'm sorry, Oxford and Cambridge, but I decided to drop all of the online definitions I quickly found, which would be likely the definitions that my mom would stumble upon if I told her that I were to watch streaming or that kind of thing, okay? So let's build on top of the last definition we had, which is the closest to what we are looking for. So streaming is a method of transmitting or receiving data in motion over a computer network. Note here that things are no longer unidirectional. It's not only about watching or listening, but it's also about sending data back and gathering feedback while the data is in motion. And of course, it's over a computer network in such a way that it doesn't limit us exclusively to the internet only. That means that we can do streaming without the internet, right? Let's continue. So as a steady continuous flow, which means that this process never ends. It functions somehow as in a loop, okay? And here is the first extension that I added to the definition, with one or more data processors along the way. Because after all, something has to be done with all that data that's in motion, right? Otherwise, it kind of loses its purpose. Continuing with our extended definition, allowing for fast consumption while the rest of the data is still being received, which means that the overall idea of this model is to avoid long periods of wait before you can consume some content, whatever that content is. And the last extension to our definition that I added, back it up by a storage layer for data persistence and consistency, which is kind of obvious. All this data sent over, the feedback, the processing that we do with it, etc., eventually needs to be stored somewhere so that you can then make some value out of it, right? So as a follow-up from our streaming definition, let's quickly understand how a streaming architecture works. I brought two examples for us today that we are going to be walking through real quick. So the first one is Grab. If we look into the left-hand diagram, we can see how Grab feeds event source to Apache Kafka, process these events, and ultimately ingests the result into ScyllaDB, which can then become available for consumers. Among many of the use cases that Grab currently leverages ScyllaDB for, one of the most fascinating ones is their real-time fraud detection, allowing them to quickly respond to potential suspicious activity. Now, onto the right-hand diagram, we can see Numberless Synapse platform, which is their core marketing engine. Similarly, as we have seen within the Grab architecture, there are event sources, which are then fed to Kafka, processing is done, and then the result is stored into ScyllaDB. After it's stored, it is eventually distributed to their partners. So speaking of Numberly partners, here's a test for you who is currently watching this presentation. Please take a look into the first partner presented in Numberless architecture. This one over here that I'm currently hovering in my mouth, Chunder. You may be seeing this name coming up again in this webinar, okay? Just for you to know, Numberly recently spoke at our last Scylla Summit, demonstrating how they replaced Kafka only with ScyllaDB and Rust. If you are interested in that, I highly recommend you to take a look at their talk, okay? As you can see, there are several similarities among the streaming architecture components, and it is really important that you understand where ScyllaDB fits into that kind of architecture. However, even more importantly than understanding where we fit, it is fundamental to understand what is the proposed value of having a database like ScyllaDB as part of it. We are going to discuss this aspect shortly, but for now, Noelle, do you understand what streaming really is now?
Yes. And now I can say that it is much more complex than listening or watching audio or video content.
Yes, it definitely is. But people here have signed up for a media streaming webinar. So let's jump straight into it. But what really is media streaming? So let's bring back one of the definitions that we saw earlier and highlight the fact that even one of the incorrect definitions for streaming mentioned that especially, not exclusively, video and audio materials are transmitted or received as a result of media streaming. Streaming media is in our daily life. How is a live conference like the one we are doing right now, or watching a video game gameplay over platforms like Twitch or Discord different from watching your favorite TV show or listening to your favorite artist? And how is it different from playing games online remotely with different people all around the world? Speaking of games, how is it different from what Epic Games is doing with their distribution of game assets in their Unreal Cloud derived data cache solution? Let me give you an overview of what Epic Games is doing. As you all know, game development is something very complex and very often requires multifunctional teams all around the world to work together. With the pandemic and people working from home, how would they all be able to have access to the same large amount of files required for cooking? That's the term that they use for cooking a game, and ensure that everyone had access to up-to-date contents. If you are interested in learning more about Epic Game Solution, ensure that you watch their talk in this last ScyllaDB Summit. However, the main takeaway here is that I want you to keep in mind how streaming media has been recently spreading to pretty much everywhere, up to a point where we may not even notice it anymore. Quite amazing, isn't it? So if we move on to talk about media streaming in the strict sense of video and audio streaming companies in the market, these are just a few of the companies currently leveraging ScyllaDB for their use cases. Hulu provides both live streaming and on-demand streaming to over 25 million users. Triton Digital is a services leader to the digital audio and podcast industry and operates over 80 countries. Disney Plus Hotstar is an Indian subscription video streaming service with over 60 million subscribers. Tubi is a content platform and ad-supported streaming service who reached 64 million monthly active users. Z is the company behind Z5, an Indian video subscription service with over 57 million monthly active users. And Comcast, as Noeli introduced us, is powering all DVR scheduling with ScyllaDB. As you can see, these are huge players within the streaming industry, and they are now using ScyllaDB. Why? Well, let's discuss some of the challenges of content streaming in the first place. Media streaming requires low latency, period. No company in the business can afford their reputation if their users are constantly seeing circling hills or waiting for too long, especially because the whole streaming experience assumes that your customers enjoy their time, right? Lower latencies as a result help avoid end user frustrations. Distributed NoSQL databases allow you to scale beyond the limits of a single server. That, combined with the power of distributed processing, makes NoSQL a very good ally to streaming use cases as a data store. Fairly often, we see many companies making use of a NoSQL database along with an external caching solution to reduce latency. One of the media streaming companies we've worked with was heavily relying on Redis as part of their use case, up to a point where they not only started having problems and an increased maintenance overhead, with keeping their cache in sync. And also the cost, the overall cost of the solution at scale started to become an impediment, okay? Media streaming also requires high throughput. Remember when we spoke that data is not only sent, but also is received? Well, you need to have a platform capable of doing very rapid ingestion. Similarly, to ensure user experience, you also need to be able to retrieve data fast. Otherwise, you will introduce a bottleneck in your streaming architecture, and everyone is going to struggle. NoSQL databases backed up by a LSM3 storage engine, such as ScyllaDB, are widely known for their high ingestion volume, as data always gets appended, which in turn results in higher throughput. I also worked with a media streaming company amid an acquisition with an urgent need to sustain a much higher throughput than their previous relational database was originally made for. DynamoDB, Cassandra, ScyllaDB, and CockroachDB were all the solutions evaluated at the time. And ScyllaDB eventually won as it could sustain the required throughput for a prolonged period of time without any kind of throttling and with lower latencies and under a much better and lower TCO. Okay. Geo-replication is also very important. There are several reasons for this. First, it allows for an enhanced user experience. Lower latencies as the data is closer to the user. However, it also allows you to do what we call smart replication, especially when you have a need for specific content, which is only supposed to be available within a certain region. Notably, geo-replication also permits you to reduce costs without you having to duplicate your entire data set across every single region that you operate. There are many possibilities here. And NoSQL databases such as ScyllaDB allows you to easily scale beyond the boundaries of a single region in an active configuration. A major concern onto geo-replication, a major concern that I found during one of my previous engagements was around the replication lag across different regions. And what we did was we've conducted a careful analysis comparing our results with different NoSQL vendors and proved that ScyllaDB replication happens almost as fast as the network round-trip time between regions apart from each other, while other databases may take a considerable amount of additional time to replicate your data properly. Okay? No streaming platform can tolerate going down ever. And note that by high availability, I do not only mean zero downtime alone. How is your platform going to react over peak traffic, such as the Super Bowl or the Indian Premier League? With ScyllaDB, we support these events, these live events, and more. In fact, I personally monitored the behavior of a ScyllaDB cluster during a few of these big events and watched the overall cluster health state, such as the availability of all known P99 latencies. And I was checking whether any error would pop out during the event, etc. And all the experience was very smooth without any issue. And of course, all those requirements for mid-streaming are great. Low latency, high throughput, geo-replication, high availability. But what's more important is no company has unlimited money to spend, right? I'm sorry. Not only the solution needs to be cost effective, but also the maintainability and its operational overhead are also to be considered. So everyone has probably seen the headlines about mid-streaming operations trying to save costs to become more competitive. And a large mid-streaming company we've recently been working with was suffering from astronomically increasing bill from their serverless solution. If you have a high throughput use case and you are getting billed by the number of operations you run, I highly encourage you to compare the numbers you've got against ScyllaDB's TCO. Most of the time, people get fairly shocked, and that's true, when they realize how less expensive their workloads can get. Okay? Now, let's take a closer look at how ScyllaDB helped mid-streaming companies and use case especially. Disney Plus Hotstar migrated to ScyllaDB Cloud and replaced their Redis and Elasticsearch as part of their migration. One of their use cases running on top of ScyllaDB is the continue watching functionality. As a result of their migration, they are now seeing sub-millisecond P99 latency for both reads and writes. And by the way, sub-millisecond essentially means that their P99 latencies are in the magnitude of microseconds. Okay. Tubi reduced their latencies from 300 milliseconds to 10 milliseconds on their machine learning features for use case. And they have extensively published about how using ScyllaDB greatly boosted their machine learning development agility, in addition to providing an enhanced user experience. And Comcast, they had a very large Cassandra deployment, as you can see, 962 nodes, which got reduced to only 78 ScyllaDB nodes after the migration, resulting in a capital huge cost savings, and believe it or not, improved performance. All these users and more are currently using ScyllaDB behind their entertainment use cases. And we are providing you with reference material where you can learn more, not from us, but from them, about their reasons for choosing ScyllaDB. But how was ScyllaDB able to reduce costs, improve latency, while sustaining high throughput for these users? Well, let me turn over to Noeli, who is going to provide us with a quick overview of the ScyllaDB architecture. Noeli?
Thank you, Felipe.
ScyllaDB is a highly scalable distributed database with unique design decisions taken from the ground up. We are built in C++, which means that there is no garbage collection pauses affecting our latencies, nor the overhead of a middle-tier framework, as it happens with Java, for example. Many databases are developed in C++, so looking into this simple characteristic at first glance has nothing special. On top of being built in C++, our programming model follows a shared nothing architecture, where we avoid many performance bottlenecks as typically seen in regular databases. ScyllaDB is built on top of C*, a high-performance C++ framework for designing data-intensive applications. And C* is used not only in ScyllaDB, but also across other high-performance implementations, such as Redpanda and the Ceph storage engine. ScyllaDB has a shared per-core architecture, which means that your data is shared by CPU, effectively making our limit being only the hardware where you are running on. Along with shared per core, we introduced the concept of sharedware drivers. That is, a client-side functionality to connect not only to ScyllaDB nodes, but also to the CPUs on which the data you are reading from or writing to resides. All these decisions essentially make ScyllaDB a distributed database with unlimited horizontal and vertical scalability. That means that node sprawl problems, as seen across many vendors, is not an issue with ScyllaDB. We are backed up by a team of engineers who are passionate about performance. Our engineers are long contributors to the Linux kernel and have a deep knowledge of systems engineering. As a result, a single millisecond for us is already too much of a wait, and we strive to always provide users unparalleled performance. ScyllaDB also has an auto-perform tuning feature, which means that, unlike most other databases, you don't have to worry about tuning the underlying Linux kernel for better performance, nor play with any garbage collection setting whatsoever. Our auto-tuning is not simply limited to system configuration. Our database implements a concept called scheduling groups. Databases have many background tasks that they need to run in order to function properly, such as flushing main tables, compacting our data, recycling the commit log, and so on. All of this needs to be done without interfering with the user-facing workload in order to ensure that latencies are in check. As a result, our scheduling groups essentially implement a dynamic priority mechanism, allowing the database to adjust its background tasks over time to prioritize work when the system has free resource and deprioritize them when the user-facing workload demands more system resources. All of this is done dynamically without you having to intervene. That was the CLDB architecture at a glance, Felipe. Let's move on.
Thanks, Noeli. Yes, let's move on to use cases, which is perhaps the section that most of us are waiting for. But before we actually start talking about use cases that are currently being used on top of FluentDB, I want to make a pause here and let's do a quick brainstorming session before we start discussing those use cases. In this brainstorming session, let's consider all the interactions that, well, some actually, that happen when a user is going to interact with our platform. In order to help us do that, let's also again bring up our original disambiguation of the streaming word. And now we are highlighting the fact that streaming is not only about transmitting things over, but also about receiving data. Okay, so here's how this brainstorming goes. Typically, when you are going to use a streaming service, you will typically open an app, okay? And as a result of opening an app, we need the streaming platform needed to verify whether our subscription is still active. Should we be opening a subscription-based streaming solution? Then it's important for the platform to collect data around our device, such as what is the software version that we are currently running on, whether the device that we are using is tampered with or not, and continuously collect telemetry data in order to know how our users are making use of our platform and also to improve our own product, right? Those are things that are very basic for any streaming platform nowadays. On top of that, we also need to check the user device location, either because there may be some regulations which forbid a specific set of content from being available within the user's region, or in order to personalize the user experience to the location where the user is currently at. Then, when we are finally going to stream something, we need to verify whether, for example, that account hasn't reached out to their account limit, in case they have any. In summary, the possibilities here are endless. So why have we done this exercise exactly? One of the things that I see most people are struggling with is that many times they don't know which use cases they can bring over to CLDB. And this is not only specific to made streaming, this is in general. So you have your company has a set of use cases, but they simply, either they don't have a use case or they don't know which use case would be a good fit or something alike. Look, just by doing just very simple brainstorming, how many interesting use cases we have collected over here, simply by quickly thinking from a new end user's perspective. Therefore, as Noeli said in the beginning of this presentation, more than often, you probably have a use case that is a perfect fit for CLDB, and you just don't know it yet. And if you really think that you don't know, try running an exercise like this. I'm quite certain it's going to assist you in the long run. All right, now, let's now discuss some use cases which we are aware people are using CLDB for. And by the way, the ones I'm going to present in here are the ones we are aware of. If you are currently using ScyllaDB and you would like to share with us details about your use cases, let us know. We'll be more than happy to add it and even invite you to host a webinar such as the one we are doing here so you can discuss how ScyllaDB is helping you out. Okay, so the first use case that we are going to discuss is the stream metadata store. As you know, if you are doing on-demand streaming, your files typically need to be stored somewhere, such as in a CDN. And many times you will be breaking up your content into smaller chunks and sending these chunks separately to your viewers. In addition to that, people stream content in a variety of ways. Nowadays we have 4K, Full HD, HD, with a variety of audio languages and perhaps even different subtitles, right? Similarly, many live streaming companies may also have a need to allow users to rewatch, rewind, and forward through a specific live show in such a way that this use case requires a very high level of throughput. For example, we've helped a mid-streaming company seeing scaling problems with their relational database. Their use case grew too large for what a single hardware could handle, and attempts to implement data and load distribution across multiple tenants proved itself to be not only complex, but also with a latency, but also came with a latency impact, and the solution was very cost prohibitive. The solution to the switch to ScyllaDB was simply revisiting their data modeling, and everything else worked smoothly. We then get to recommendations, which is essentially the content that's going to be recommended for a user to watch. It is personalized per user and based on its previous interactions with the platform. Here, low latency is very important, as you don't want to delay the entire process of a user entering your platform just to present them with a recommendation view. The reason why such a use case shines on top of ScyllaDB is because it's tightly cacheable. For example, it's very easy for us to imagine that a given show will be recommended for a variety of users which have similar viewing habits. As a result, ScyllaDB specialized cache implements a least recently used eviction policy, which guarantees that frequently used data will always be delivered as fast as possible back to the application, guaranteeing you lower latencies. We then get to content caching, which is essentially the catalog of everything that's currently available within our platform. For example, a move catalog may have details about actors, a summary, age restrictions, the length of the show or movie, release year, and so on. Similarly, depending on how your streaming service works, you may leverage geo-replication to ensure that your data is readily available across multiple regions or only within some. Some of the challenges that geo-replication involves are typically around the time it takes for the data to get replicated from one region to another. And remember what I said before. With ScyllaDB, we have been able to lower the replication time as close as the network round trip time across regions, which means that ScyllaDB replication is super fast, as your network allows, of course. Playhead tracking. I particularly love this one. This use case is also known as playback tracking. That is essentially Disney Plus Hotstar use case that we have seen before, the continue watching feature. This kind of use case is somewhat tricky, as it is because it's very susceptible to receiving out of order data from the client. And in particular, proper care must be taken during the migration steps to avoid data loss at the expense of end users losing their viewing histories, right? And lastly, we have the machine learning feature store, as Tubi is currently doing, which essentially combines online processing with analytics in order to provide user a real-time experience and empower their data scientists to gather feedback close to real-time over their user behavior. Now, I want us to make a pause here again so that we can understand a bit deeper on what Tubi is currently doing. How come are they using it for both online and analytics processing at the same time? Noelle.
That's a very good question, Felipe. One of the capabilities of ScyllaDB is to completely isolate workloads one from another, allowing the database to prioritize certain requests over others. For example, we know that OLTP types of workloads are notoriously more latency sensitive than analytics workloads. As a result, you can tell ScyllaDB which workloads it should prioritize, and when there is system contention over resources, the database will prioritize our most latency sensitive requests over other workloads. Workload prioritization is built on top of the scheduling groups concept that I explained earlier, and it enables you to further extend your use cases under a single data store. Does that help, Felipe?
It definitely does. Thanks, Noelle. And this essentially brings us to the last part of our presentation. Let's talk now about the future of streaming media as we see it. Well, streaming media already gave a clear sign where it's heading to. More specifically, when Netflix announced last year that they would be supporting a cheaper subscription type with ads, and more recently, this subscription tier was publicly announced. Similarly, connected TV and over-the-top advertising is a billionaire type of industry. So what's next? If you ask me, I don't think the real future battle is going to be between dongles versus smart TVs or anything like that. I think the path is clear in that area already, and some players such as Roku already started transforming their business. Similarly, streaming devices are going to remain for quite a long time. But one thing is for certain, no matter whether you are using a dongle, a box, a mobile phone, your video game, or your laptop, streaming media will continue to grow, and it will expand to even more interesting use cases, past simply audio and video consumption, as we have discussed. So, what is the future of streaming media? Well, advertising is coming to it. And for those which are already having some sort of advertising, I believe that with it, new challenges and ways to create personalized, interactive, and engaging content are coming. And what's special about the three logos featured in the screen? For those of you who are along with us since the beginning of the presentation, you probably saw Shander when I called shout out for Shander. So let's start with the first one. Shander, formerly known as AppNexus and recently acquired by Microsoft. They are the company behind Netflix subscription services with ads. Firework HQ is a live streaming shopping and shoppable video platform, allowing the creation of engaging experiences. And Arch19, now an Amazon company, is a key player within the audio industry on advertisement, publishing content to several audio streaming platforms. So then you may ask me, Felipe, what do all these three companies have in common? Well, they are all powered by ScyllaDB. So if you ask me, the future of streaming is along with ScyllaDB.
Awesome. Thank you very much, Felipe. So before opening the Q&A session, I would like to encourage you to try a free trial by spinning up your own cluster on Scylla Cloud Portal and take the opportunity of keeping up learning at ScyllaDB University. Also, I recommend you take a look at our upcoming Linux Foundation session. Really valuable content there you will find. Felipe, shall we start the Q&A? We have already some questions, eager for answers here.
Yes, of course. Would you like to ask the first one?
Sure. From Alexander. Alexander, can we assume streaming of events, not streaming of video or audio? So I assume that you have explained a bit about it. So would you like to
Very good.
add that, Mark?
Yes. No, Alexander is perfectly correct. Of course, you are not going to be using a database to do to string the largest payload of your main use case, which is video or audio. You typically will rely on some other solutions such as a CDN, and you will probably going to store everything in some sort of cheaper storage, such as Amazon S3, GCP, cloud storage, or Azure blob storage. So yes, you definitely can assume event streaming and not streaming of video and audio. But the whole idea of this webinar is to know how you can integrate your event streaming for your mid-streaming type of use case and how you could use leverage Scylla along with it. Yeah, that's a very good question. And as you can see, it's very hot currently in Brazil because I am drinking water like non-stop. Do you have any other questions? Noelia, I think you are on mute. You are like
I was on
speaking
mute,
to...
sorry. So yes, Alexander was dropping another question. Is there a direct connection from Kafka to ScyllaDB?
Yes. So another very good question. So we have a Kafka sync connector, and we also have a Kafka source connector. So if you want to string data out from ScyllaDB and process it within your streaming pipeline, you can. And you can, of course, use ScyllaDB as your data store for events. So we are fully compatible with Kafka, either for inserting or for retrieving events.
Okay, and Aparna is asking, how frequently do you update the fully managed service?
It's not clear whether I understand the question. Maybe you mean the ScyllaDB version? Would you like to talk about our release lifecycle, Noelia?
Sorry, once again, Felipe?
Would you like to talk about our release lifecycle? I think that may be it. How many enterprise versions we have per year, or long-term supported version, short-term supported version?
Yeah, so for long-term support versions, we have one release every year. And on top of that, we have around 3 or 4 short version release, if that's what Aparna did. But if we got the question wrong, please elaborate that for us.
Thank you.
There is one more. If there is an outage which happens in AWS services for some regions, how do you mitigate? So, well, this is why we are a high availability NoSQL database, right, Philip? So if we have the right replication between data in different regions, different availability zones, we can ensure that if you have, by any chance, any nodes down, we can keep serving, the database can keep serving data with all other nodes up. If using, with a consistency level, like good or, but Philip, if you would like.
What I would like to complement from your answer is that regional outages in AWS are very rare, but you're right, still they do happen. In general, if you want to have regional well, a disaster recovery setup, what you really want to do is to ensure that your cluster is multi-regional. So if one region entirely goes down, you simply switch over your user to a different region. That's it. Because AcelaDB has this active setup, you don't need to do anything else other than simply switching over your application.
Very good, Felipe. Thanks. Does Scala support Pocket or Arrow? Is there a way to work with these formats in Scala?
So not directly as a storage engine. You probably can integrate with Spark or something like that and then ingest into Scala. But the current protocols that we support are essentially SQL, the Cassandra query language, and also the DynamoDB API, which is via HTTP. Our storage engine essentially follows a binary format. So in order to ingest data to Scala, you need to use one of the binary protocols that we support. Okay. We did have, if you look into Google, if you probably have to Google ScyllaDB and Parquet. We did conduct some studies on how we would integrate Parquet with Scala. It was purely a hackathon, and we proved that it's possible to make it work. So if you have a real business use case where you feel like you would leverage Parquet, I would recommend you to go to our GitHub and request support for Parquet as a storage engine as a feature. Okay.
Dinesh is asking, can you please briefly explain how does ScyllaDB replace Kafka plus Elasticsearch, primarily used search engine in Hotstar?
Yes, definitely. So we unfortunately don't have time to dive deep into Disney Plus Hotstar use cases. What I can tell you is that I think there are 2 or 3 videos where Disney Plus Hotstar mention themselves on what they really on everything that they did. On top of Kafka and Elasticsearch, they also used Redis. So that's essentially everything that they integrated in order to switch to ScyllaDB. I highly encourage you to check their talk, and because it's essentially a 1-hour webinar specific on what they did. Okay.
All right. So for now, no more questions and Q&A. Ah, there is one more. Where will application server reside?
Do you want to answer that one, Aile? Before using Scala, where should your application be located?
On a separate server.
Yes. So typically, ScyllaDB is a low latency database. You will want to place your application very close, typically in the same region, perhaps even in the same availability zone than your existing ScyllaDB deployment is. And of course, you will want to use a different server because you don't want your application to hurt your database performance while running it. But your application can run pretty much anywhere in Kubernetes, VMs, Docker. We have seen people doing all sorts of things. So ideally, you can follow the very same practices as you have been following already with other databases, application-wise.
So let's see if I'm missing some questions into the chat. That's all of that. One of the guys are asking, yes, we will have this recording available later. We will send you over the email. So
Don't worry if you miss the first part of the presentation.
Great. And I see we only have 2 minutes left. And I think with that, I would like to thank everyone for their attendance. Thank you, Noeli, for hosting this webinar and for taking the time to help me out.
Thank you a lot,
Any
Jake.
last word for the day, for the May the 4th?
So, drink water.
Drink water, yes. Thanks, everyone, and see you next time.
Thank you a lot. Thank you. Bye.